With our scene setup, let's get started. First, we need a texture coordinate node. Let's use the object texture coordinate, as it is aligned with the object transformation, so whenever we transform our object, the coordinates will be carried along with it. We've been looking at the texture coordinates as vectors, but we can also think of them as each individual component of the vector being an infinite gradient along one of the axes. We can access these components with the separate XYZ node. Here we can see each component's gradient, though there is not much going on with Z as the whole mesh has a Z value of 0, being on the XY plane. To create our bricks we need a repeating pattern, kinda like an array modifier. For this we can use the fraction operation of the math node, which tells us how far a value is from the first integer below it, basically discarding the integer portion of the value and just keeping the decimal part. If we do the same thing for the y-axis and join the resulting coordinates with a combined xyz node, we get repeating coordinates that are effectively UVs of squares with a size of 1 unit. This setup was good for understanding what's going on, but let's get rid of the whole thing because a much easier way to do this is using the vector math node, which allows us to do a bunch of vector-specific operations, but also allows us to apply many scalar operations to all three vector components at once. This new method created some artifacts. Let's use a separate XYZ node to inspect this. Everything is fine with the X and Y channels, but clearly the issue is in the Z channel. The problem is that due to precision issues, whenever EV samples a point on the surface, it can come up with a value slightly above or slightly below 0. And because our function is discontinuous at integers, this makes the output jump between almost 0 and almost 1. To fix this problem, in this case we can just multiply the Z coordinate by 0, as we are dealing with a plane. A useful tip is to regularly orbit around the viewport, as these kinds of issues don't always show up in certain views, or at least are more difficult to spot with a static view. This tiled pattern will allow us to repeat whatever we do across all tiles identically, but we might also want to uniquely identify each tile to be able to add variation, and for that we can use a floor operation. This will give us a constant unique value for each tile. In fact, this is the complementary operation to the fraction, as it gives us the first integer below a value, discarding the decimal part. And indeed adding these together will give us back the original coordinates. One more thing we'll need is a random value for each tile. We can later use this to randomize things like shape and color. For this we can apply a white noise texture to the tile indices, which generates a completely independent random output for any input value, meaning that no matter how close two input values are, unless they are exactly the same, the outputs will be completely different. Here again we see a precision issue, and it is again a problem with the Z channel. We multiplied the Z channel by 0, but here we still get the precision issue because due to the way numbers are handled, a value of 0 can be positive or negative, leading to different results. But as we don't need the Z channel anyway, we can just switch the noise from 3D to 2D, making it ignore the Z channel, which incidentally also makes the computation slightly cheaper. We can now turn this basic tiling setup into a convenient node group with Ctrl-G. If we just group the nodes like this, we get the same input coming into the group twice, as Blender handles each connection separately. So let's undo that, and first join these connections with a reroute, using Shift right click and drag, and with it selected as well, we can now create the group. Then it's just a matter of connecting the remaining outputs. The random output creates a color socket, but I prefer to use a vector socket by first connecting it to another vector socket. Doing this is not necessary, but I like to do it as this is a utility value, and this makes it easier for us not to confuse it with something that we actually want to use for color. With the sockets sorted, let's just give everything some proper names. The first socket is our main coordinate, so vector is already a reasonable name, given that it's pretty much a standard across Blender. The second socket is our floored coordinate that we'll use for accessing each brick by index. And lastly, we have the random value from the white noise node. Now let's tab out and we can name the group itself. Lastly, it would be nice if our bricks weren't just squares, so tabbing back into the group, let's add a vector multiply node in here so that we can independently scale each axis. And to make it more convenient, we can use a combine XYZ node, fix the X value to 1, and only expose the Y value to the group, allowing us to control the bricks ratio with a single value. Then we can neaten everything up by holding Ctrl while moving the nodes to snap to the grid. Finally, we can set our desired brick ratio.